Hello, I'm going to give a demonstration of a project I've been working on called Menorah, which is sort of an experiment framework for feeding data from Riverview into NuPIC. More than one stream of data specifically, that's why I wanted to do it, so that I could swarm over multiple fields of data to get the best parameters for one predicted field in the data, and feed each different field from a potentially different river or a stream in Riverview. So here's where it's located, NuPIC community, Menorah on GitHub. Called Menorah because as I was drawing out the idea on a whiteboard, I kept drawing this figure and three different people commented at different times that it looked like a menorah. Why was I drawing menorahs? So I decided that was a good name. Anyway, here we go. Get this out. So I'm in Menorah right now. And let me show you the example scripts that I'm going to be running. So here's example 1. And it is going to fetch data from one stream. This one right here. And if we look at that on Riverview, you'll kind of see what the pattern looks like. There you go. So we had a gap when Riverview was down, which was a stupid mistake on my fault, but it generally looks like this. There's a very daily pattern happening in this. This is energy demand data from Texas. So if we run this, so we're basically taking the river name, which is ERCOT demand, which is here in the URL, the stream name, which is system-wide demand, and then the demand field out of that stream, which is the only field, if you look at it, that exists besides daytime. So a very simple example. And we're going to use this array that identifies each stream, which is an array of arrays. And those are going to be basically our identifiers for the data streams. And this string is a working directory. So I want this to go in a directory called work and example one field. I already have that here, so I'm going to delete it so we can see it from scratch. And then once I've created that Menorah instance, I'm just going to call swarm and run model, which you must have a swarm before run model, but I'll show you once you've swarmed, you don't need to swarm anymore. So here I am in the Menorah directory. I'm going to run Python examples, example1.py. And there we go. It is collecting a bunch of data. Got 5,000 rows of data, and now it's swarming. I'm going to speed this up now so you don't have to watch it. Okay, we're back. That took a really long time to swarm, but at the end of it, we got our field contributions that tell us that obviously the demand itself has a high contribution, and the day of week and time of day also have high field contributions. And then it just starts running the model, and it just outputs the error over time as it's reading records. And it will continue to load data from Riverview as it runs out in its local cache. It'll just go to the next, the next, the next. So now we can see it wrote a bunch of data into this work directory. So let's take a look at that. In our work directory, example one field, excuse me. Let's see. Thought I had this Zoom thing enabled, but apparently I don't. Work example 1. So we've got a data, CSV, our model params, our swarm directory, and then prediction. So all the predictions go into this CSV file, and this data, CSV, is the input data. So you can look through that. Also, if I go back to the file is running, I'm going to comment out the swarm. So I don't have to swarm anymore because there's already all the swarming details, or excuse me, the model params here. So if there's model params from the previous swarm, you don't have to swarm anymore. And I'm going to tell it plot true. So I think if I just run this again, it will get a nice plot. It always pops up underneath somewhere. There it is. And there we go. This is energy demand in Texas over time, and a live NuPIC model running in the background, plotting to the screen. So this will keep going and going. So that's another way to visualize it. Just turn plotting on. I'm going to kill that. So other examples I want to show you is, here's an example of running multiple sources. I'm not going to run this because the swarm's going to take a long time. But it basically will just set up a multi-field swarming for assuming that the predicted field is the first source in this list of data sources. And then I'll write it to this output directory. And so it'll find the contributions from these other fields, which in this case won't be anything because it's just an example. So here's how you do it with multiple fields from Riverview. Here's how you can do it aggregating. So if you look at the Portland 911 river, you will notice immediately that while it is a temporal data stream, it's a geospatial temporal data stream. So there's no real scalar value associated with each of these points. There's a date time, a latitude, and longitude, which you could interpret as scalar. But really, these are just events over time. But one thing you can do is show the aggregation of these over time. This plot doesn't work right, apparently. But if you tell it, okay, I don't want to get a particular field, I want to get the aggregated count of how many events occur every 15 minutes. That's what this will do. So that'll dump into a different working directory called example3, aggregated. And you can also tell it since this time. I think I showed that in another one. But so it basically does the same thing, except it gets the count of that over time, not a particular field. Here's an example of just creating the CSV, which sometimes can be useful. So you create I'll just run this real quick. Python example 4. This shouldn't take too long because it's just going to pull a bunch of data from Riverview and stream it into a CSV file. So for each one of these rivers, it's just loading up to 5,000 data each. And now we've got our data file. So you can swarm over this directly. So it's going to be useful to show charts of Riverview data that are coming from different sources. So that's useful. And the last example that I want to show you is how you can use an aggregated field in addition to other fields that are not aggregated. So this would give you the tree debris count every day, and it would also include humidity, rain, wave height in Chicago. And then in this one, like I said, I'm telling it, oh, here's the right way to do swarm params. I'm sorry. You have to do it in you have to give the proper key, swarm params equals. So you tell it swarm params large to run a large swarm. And this will take a long time, so I'm not going to show it. But so the main point of this is if you can get if you can get data in Riverview, you can do a lot of interesting experiments with it. So after this whole challenge thing is over, I'm going to try and get more and more relevant data into Riverview, especially data that should be correlated with other data, because I really want to have some good examples that are easy for people to run, that show like this prediction is assisted by this other field. Like predicting this field is predicted better when you have contributions from this other field. And we don't have any really clear examples of that. I mean, we've got date and time, but that's not nearly as clear as showing that weather affects X, Y, or Z. And I think we can do that if we get the right data in here. And this would be easy for anyone to come along and experiment with different data sources. So that's my demo. I haven't pushed this a lot on the community, but I want to create some more demos with this as time goes on. And I encourage you guys too, if you have any ideas about the data in rear view you think might be interesting or might correlate with each other, try it out. Have fun. Thank you.